you guys should know by now that problems are not going to stay as easy as the ones we did in video 1. You're not always going to be given an equation that's already solved for both variables so that you basically just get to set them equal to each other. Life's just not that easy. So here we're going to do some examples where one of our equations has a variable isolated, but the other one doesn't. So it's still just a matter of substitution. All you're going to do, I know that y is equal to negative 2x minus 1. So I'm going to go into this equation here, and in place of that y, I'm going to put negative 2x minus 1. Now you are going to have to utilize parentheses here because I've got 2 multiplied by y, and y is going to suddenly become 2 separate terms. So in order to make sure that I still am multiplying all of y by 2, I'm going to say 2 times negative 2x minus 1 because I want to multiply this entire expression that's equal to y by 2. And we do that through parentheses. And then equals 12. So notice everything else up here is staying the same. I've still got 4x, I've still got equals 12. The only thing I've done is I've taken out my y and I've replaced it with this negative 2x minus 1. And now I'm going to solve my equation. I'm going to distribute first, because it's a multi-step equation. 2 times negative 2x is minus 4x, or negative 4x. 2 times negative 1 is, negative 2, is negative 2, and that equals 12. Well, 4x minus 4x is 0, so that's completely gone, and what I'm left with is negative 2 equals 12. Well, that is not true. Remember back in lesson 1 when we were graphing, we knew we had no solution if the two lines didn't intersect. Here, I'm going to know that I have no solution if I'm left with something that is not true. Negative 2 does not equal 12. That means never are these two lines going to cross each other. So I would say no solution. If you wanted to graph that, you could see that these two lines will have no solution. I went ahead and put these two equations into Desmos, which is a graphing tool online, and you can see that my negative 2x minus 1 is this red line, my 4x plus 2y equals 12 is here, and those two do have the same slope and they never intersect. You don't have to graph it every single time, but I just wanted to show you guys that getting a no solution kind of result here does correlate with the graphing of two parallel lines. Okay, so this one had it solved for y, and we plugged that in for y. This one has it solved for x, so guess what we're going to plug in? We're going to plug it in for this x. It does not matter which variable you have isolated. I know we spend a lot of time solving for y because it helps in the graphing process, but as long as one of your variables is isolated, you can use the substitution method. That's part of why I like this method so much. So I'm going to take negative 2y plus 5, and I'm going to plug it into this x. So again, I'm going to need some parentheses because I'm multiplying this 2 by all of 2y plus 5. And then I've got that plus 4y equals 10. And I'm going to start solving the exact same way. I'm going to distribute. 2 times negative 2 is negative 4y. 2 times 5 is 10. And then that 4y is not getting distributed because it's not part of the parentheses. And now I'm going to combine like terms. I've got negative 4 plus 4. That goes to 0. And 0 plus 10 is equal to 10. So we got all our variables disappeared. We got a solution that is true. That, just like when you're solving equations, means we have infinitely many solutions. If you wanted to see this graphed, this is just my x equals negative 2y plus 5. If I turn on this 2x plus 4y equals 10, you'll see that it turns orange there and shows up right here in the same spot. So they do indeed have infinitely many solutions because they're the same line. All right. You guys go ahead and try a couple. Yours aren't guaranteed to be infinitely many and no solution, but you're just going to be substituting this in for y, substituting this in for x, and getting your solutions. Be sure to check your answers, and I'll see you on the other side.